We are living in a world full of technology. Years ago, students who were homeschooled used only printed material. Distance learning was done through using the U.S. Mail Service. But with the adoption of the Internet, distance learning has become faster and easier to accomplish. Students are able to take classes in between trips to the office, picking up the kids, and running on a treadmill at the local gym. While this type of learning fits well for people who have active lifestyles, there is very little, if any, interaction between students. However, with the creation of virtual environments, students are finding ways of overcoming this isolation by joining 3D virtual world environments. This presentation will be to look at how the technology of 3D virtual worlds can be used in education. We will look at 3 research articles focusing on how virtual worlds such as Second Life, Active Worlds, and Move are used in building student engagement, collaboration, and successful learning outcomes. Presentation objectives. After this presentation, you'll be able to explain the difference between each 3D virtual world, be able to use Second Life to conduct a discussion using either the jigsaw or fishbowl method, be able to use chat features in one of the virtual worlds, be able to tell 3 important findings of the River City project. History of Second Life. Second Life was created by Linden Labs in 2002 as a virtual environment for Linden employees to test their hardware. Initially known as Linden World, and used as a 3D shooter game where users created worlds with realistic terrains, buildings, guns, user-created creatures, and weaponry used to shoot at buildings and the terrain. In October of 2002, the beta of Second Life became open to the public, where users were able to create avatars and interact with other Second Life users. Users were also able to purchase land using Linden dollars, build their own virtual worlds, and visit other regions. History of Second Life continued. In 2007, graphics were greatly improved and voice chat was added to provide users with the ability to use their own voices to chat more realistically with other Second Life users. Because of Second Life's graphics and voice abilities, and the ability to create custom worlds, colleges and universities started subscribing to Second Life in order to enhance the college experience for their students. Overview of Second Life. User worlds containing rich immersive environments, customizable avatars with the ability to purchase accessories for these avatars. Users can also interact with their environment by clicking on objects. Users can toggle between first-person and third-person views. Users can chat in real time using the chat feature as well as using their microphones to speak to others. In this slide, we see an example of a 3D virtual library at SUNY Plattsburgh. Notice the avatar standing in the library. This is the avatar that we created for this presentation. We used the following article to look at how Second Life was used in education. The aim of the research was to assess the applicability of Second Life for collaborative learning. The authors state that students learn better when they work in groups. Students who work in small groups tend to achieve relatively higher levels of academic outcomes and more likely to develop the skills needed for a successful career. This article looked at 2 methods of collaborative learning, jigsaw and fishbowl. In this slide, we see how the jigsaw technique looks. In this slide, we see how the fishbowl looks. The authors concluded that learning was enhanced by several of Second Life's affordances and metaphors, combined with the project-based instructional design. They liked how students were able to customize their avatars because it allowed students to create their own identities and thus helped shy students to express themselves easier. However, the authors point out some negative aspects of Second Life that could inhibit learning. They point to problems such as ease of use, graphic intensive, open source structure, collaborative learning. Now, ease of use Second Life has a steep learning curve, and some users have trouble navigating to other worlds, as well as learning how to control their avatar. Graphic intensive, users with older machines may have problems with navigating Second Life because of the rendering and the requirements of newer computers with faster processors. Now, the problem with being an open source structure is that users from all walks of life can access Second Life, and this makes it hard to restrict user interactions. Many of the Second Life users sometimes express themselves using colorful metaphors, so it's not really an ideal place for younger students. Also, for collaborative learning, users are not able to browse the internet together or share files, which is a big part of collaborative learning. Our next section is going to be about Active Worlds. Active Worlds is one of the more popular 3D virtual worlds. It was established in 1997, so it is the oldest of the virtual world platforms. AW is a client-server application that allows developers to create 3D virtual worlds for users to visit and interact with. It can be used synchronous and asynchronously. Another feature of Active Worlds is that users are able to access this platform online without having to download huge files that can come with malware that some other platforms may include in their downloads. This 3D virtual world mainly relies on text-based chat, but offers audio chat in some worlds. Another interesting feature is that users can be represented as avatars in a 3D environment. They have the opportunity to interact with other avatars and the environment, and also choose the avatar they want to be. Active Worlds is very easy to learn and use. The user interface has 4 main windows: the 3D environment, a chat tool, an integrated web browser, and the navigational window. Active Worlds was tested by 2 groups. They are shown in Case Study 1 and Case Study 2. The first case study is a course called Business Computing Skills 1000. It was used asynchronously by undergraduate students. In the first case study, the goal of the course was to foster business computing skills. This class was commonly delivered in various formats, such as in a traditional classroom, in a web-based environment, and in a 3D virtual environment. However, in this research, the Active Worlds version of B-Core was used. All concepts were presented using Microsoft Word, Excel, Access, and PowerPoint. Students were required to do weekly assignments and group work. In this slide, you see the setting and learning context of B-Core. It is a 3D world that is made up of a spacious rectangular park that is surrounded by a background picture of the mountains that frames Boulder, Colorado. If a student moves towards east or west along one of the roads named after each of the applications, for example, Microsoft Word Lane, they will find a series of one-room buildings. Each of these buildings represents one of the different applications covered in the course. Each building represents a software application and an assignment that has to be completed with that application. Within each building, there are signs. These signs are linked to web resources. These resources help students to learn the application. If a student clicks on a specific sign, an integrated web browser is activated to load a resource website. In this slide, we see the back of one of the buildings. In the back of each building, there is a small patio that provides a place where learners can meet and collaborate on group projects. Moreover, in each patio, there are signs that are hypertext links to web-based resources for working on group projects. Case Study 2 uses Active Worlds in a synchronous informal learning environment. This case study focuses on Intro to RWX, Renderware Scripts, modeling. It is a 3D object modeling course for learning how to create original Active World objects. The Active World browser uses Renderware to display 3D environments. It relies on renderware scripts to define objects in the 3D environment. Case Study 2 uses active worlds in a synchronous informal learning environment. This case study focuses on Intro to RWX, renderware scripts, modeling. It is a 3D object modeling course for learning how to create original active world objects. The active world browser uses renderware to display 3D environments. It relies on renderware scripts to define objects in the 3D environment. This class was delivered by Majin, the instructor, in a synchronous in-world learning environment. The students that took the class were regular users of Active Worlds. The class was discussion-oriented, and the chat tool relied only on text. The text appeared bold-faced, making it easier for students to read and respond to others. Majin presented a concept of 3D modeling using the chat tool. Then she illustrated the concept using a sample 3D object in the 3D setting. Finally, the instructor presented further illustrations of how a technique or concept was constructed by providing the scripts of the object in the integrated web browser. This allowed learners to follow the RWX script and see the final object in the 3D setting. Our third and final virtual world is Move and EcoMove. Both of these projects are from Harvard University Graduate School of Education, and they are researcher created, so therefore they are not open source, and we will discuss them in the further remaining slides. The MOVE system is created in year 2000 for the River City Research Project. In the MOVE system, there is a virtual town called River City. The residents of the city are becoming ill, so students play as visitors, work together in small research teams to help solve this problem. When solving this problem, students apply their 21st century skills and technology skills. This is how they learn. In this next slide, here are some pictures of the MOVE system. Students can collect data from water samples, gather information and clues from residents, and develop controlled experiments to test their hypotheses. There were three main findings in this research. Students were able to conduct inquiry in virtual worlds and were motivated. This is actually very positive feedback and verified the effectiveness of the virtual environment. In the three MOVE groups, the one who had the best outcome is the one with teachers and mentors guidance. This indicated that the role of the teacher is still very important even in the virtual environment. Also, they found when using different assessment methods, the results were different too. A performance assessment may work better in showing students' learning outcomes than the standardized test. In 2010, the next generation of the MOVE system became available, the EcoMove. This time, the researchers' aim was to teach middle school students about the ecosystem. So this time, researchers not only focused on the virtual environment itself, but also combined it with a real field trip experience. They also developed an augmented reality mobile app to cooperate with it. We hoped you enjoyed our virtual world presentation. Please try these practice activities. Using the virtual world of your choice, create an avatar that you feel represents you. Select a world to visit and use either the chat window or your voice to interact with other users. Take a screen capture and send it to randy68az@gmail.com. Please share your thoughts about virtual environment with your friends and classmates, and try to download and use some of the open source virtual environments. Share your experience.